So, good morning, my dear students. So, myself, Dr. Dsvsmrk Chekravarty, working as an associate professor in this repeated organization since 10 years. So, today I am going to explain about the corrosion of the steel in the reinforcement. So, in the previous classes, we had discussed about what is the introduction of the rehabilitation and retrofitting of the structures. So, already we have constructed the structures. So, it is the 5 years or 10 years or 15 years or the 20 years. So, we are facing some problems. So, corrosion of the steel reinforcement problem we are going to face today itself. So, what is the corrosion of the steel reinforcement? So, in the RCC buildings, we are using steel and concrete. So, what is the role of the concrete in the RCC buildings? To take the compressive stresses and compressive stresses only. So, the main purpose of the steel reinforcement is that to take the tensile forces. Why? Because in the buildings we are subjected to shear compressive stresses, tensile stresses, shear stresses, bending stresses, torsional stresses also we are going to face. So, the concrete is very strong in the compression and very weak in the tension itself. The steel is very strong in the tension. So, that's why we are providing the steel in the concrete structures itself. So, both the concrete and steel will take equally the compressive stresses as well as the tensile stresses. So, now in this class I am going to discuss about what is the role of corrosion of the steel reinforcement. So, what is the role of the corrosion of the steel reinforcement? If you are providing the steel reinforcement in the concrete structures, how if the reinforcement will be corroded? What will happen? So, what is the mechanism? So, what are the precautions we are going to take? So, how to detect? So, what are the methods we are going to use for resistance of the corrosion of the steel reinforcement? We are going to discuss here. So, corrosion of the steel reinforcement is the durability issue. So, every building or every structure we are going to design for the strength aspect as well as the durability aspect also. Durability aspect means if the building will not be subjected to any failure against the fire or vibration or the cracking or the shear or whatever the things. So, that is the durability of the structure itself. So, that's why the corrosion of the steel is related to durability factor, not the strength aspect. The building will be designed in the strength aspect as well as the durability aspect also. The corrosion of the steel reinforcement belongs to the durability of the durability factor only, not the strength aspect. So, that's why in the concrete lab also we are testing the cubes for the strength aspect, workability, mechanical properties as well as the durability properties also. So, durability properties means acid resistance, rapid chloride permeability test or carbonation test. These are all the tests we are going to do whether the concrete will be subjected to durability factor is good or bad or any other thing. Okay. So, that's why we are designing the structures in the strength aspect as well as the durability aspect also. Why does corrosion will be occurs? Suppose I am taking a column itself. Suppose in the column we are providing the reinforcement in the two ways. One is the main bars, one is the distribution bars. So, we are providing the reinforcement in the concrete itself. Suppose if the concrete is exposed to atmosphere, automatically what happens? The oxygen will enter into the steel reinforcement, corrosion will be occurs. The corrosion will be occurs. Due to the corrosion, what happens? The strength of the bar will be reduced. The strength of the bar will be reduced. So, why? Because the steel is having a yield strength, the concrete is having a compressive strength. That's why for designing of the any structures, first of all, we have to decide the grade of the concrete, whether it is M20 or M25 or M30 or M35. And at the same time, we are deciding the grade of the steel, whether it is the FE 250 or 415 or 500 and 550, 600. So, that is the yield strength of the steel itself. Suppose if the reinforcement will be corroded, automatically the yield strength will be reduced. Suppose if you are designing a structure for FE 500, suppose if the reinforcement will be corroded, it will be reduced to 450 or 400, automatically we didn't get the desired values or we didn't get the good values or we didn't get the safe values also, safe permissible values. So that's why sometimes because of that the structure will be deteriorated, not will be collapsed at a particular time, it will be deteriorated. So that's why we have to take utmost care against the corrosion of the steel reinforcement. So carbonation is also. So carbonation is also occurs and corrosion is also occurs. So because of the poor quality of the concrete is also. So we are not blaming about only the steel reinforcement failure. So we have to take care about the concrete quality also. Why? Because concrete is a heterogeneous material. It is not a single material. It will consist of the cement, fine aggregate, coarse aggregate, water. Sometimes we are using admixtures also. But steel is only single material. So that's why we can't get the good quality of the compressive strength for summarizing of all the materials in one stretch. So that is the main disadvantage of the concrete itself. That's why we are always thinking about the good quality of the concrete. That's why we are going to test it in the laboratory, compressive strength with the help of the cubes, flexural strength with the help of the beams, and split tensile strength with the help of the cylinders also. Why we are going to test it? Sometimes we are going to test it 7 days also, 14 days also, 21 days also, 28 days also. But steel is to be tested in the universal testing machine Young's modulus. So Young's modulus of steel is generally, you know that 2 into 10 to the power 5 newtons per mm square. So Young's modulus is nothing but stress by strain. Stress is equal to load by area. Strain is equal to change in length by original length. Therefore, Young's modulus is equal to stress by strain. So if we tested a 1 feet of length of the any diameter, either the 16 mm or 20 mm or 25 mm, you have to test it in the laboratory. First of all, we have to see that whenever the bar will failures, you can note down the load by area will give the stress, the deformation, change in length by original length, we are getting the strain, that stress by strain we are getting Young's modulus of the steel. So for the steel we have to tested only the Young's modulus. So, or elongation also. So many tests are not performed for the steel, my dear students. But so many tests are to be performed for the concrete. Why? Because concrete is a heterogeneous material. It will consist of the different constituent of the different materials. Cement, fine aggregate, coarse aggregate, water, admixture. Sometimes we are using substitute materials. So instead of cement, we are using cement and fly ash. Instead of sand also, we are using sand and sand dust. Instead of 20 mm metal, we are going to use 20 mm, 12 mm, 10 mm and 6 mm also. So that's why we are going to use the substitute materials. So that's why we are going to test all the materials. We have to test cement separately, fine aggregate separately, coarse aggregate separately. Water is also tested for the drinking purpose only we are going to use. If the water is having salts or pH is less than 7, that will be harmful to the concrete, that will be harmful to the reinforcement is also. So that's why what I am trying to tell is the corrosion of the steel reinforcement is also one of the reason for because of the non-purity of the water also. So that's why the quality of the concrete we are going to see that, the quality of the cement, quality of the fine aggregate, quality of the coarse aggregate, quality of the water also. These are all combinedly responsible for the corrosion of the steel reinforcement. So what is the process of the corrosion? So it is the aniodic and cathodic reaction. Anode and cathodic reaction is nothing but that process of that. Next, effect of the what are the effects of the corrosion? Loss of the steel cross section. The main disadvantage is that because of the corrosion, automatically what happens? The cross section will be reduced. Suppose if you are using a 12 mm diameter bar, so what is the area? Pi by 4 into d square, pi by 4 into 144, that is the original cross-section area. If the steel will be corroded, we didn't get the 12 mm. Instead of 12 mm, we are getting 10 mm. So that's why automatically the cross-section area of the bar will be reduced. So instead of the 12 mm diameter rod area, we are getting the 10 mm diameter rod because of the corrosion. That is the reduce the strength also. So ultimately what happens because of the corrosion of the steel, the cross-section area will be reduced. Because of the cross-section area will be reduced, reduce the yield strength. That is the FA value, yield strength of the steel. We are having 250 grade, 415, 500, 550, 600 is also available in the market, but in the code only 250, 415, 500 is to be incorporated in the IS 800 2007 steel code book. Next, expansion of the rust causes cracking and spalling of the concrete also. So that is also one of the effect of the corrosion, spalling of the concrete. So because of the expansion of the rusting cracks, the concrete will be spalling. So that is also not advisable. Because of the spalling of the concrete also, we have to reduce, it has to reduce the compressive strength of the concrete also. That's why we are getting the disadvantage against the compressive strength of the concrete as well as the yield strength of the concrete because of rusting of the concrete itself. So my dear students, I will tell one point clearly about that. It is interlocking. It is interlocking. Why? Because it is the combination of the concrete and steel, my dear students. The corrosion of the steel reinforcement will be affects both concrete strength as well as the steel strength also. That's why compressive strength of the concrete will be affects and yield strength of the concrete is also affects. Ultimately leads to the structural failure. My dear students, I am telling no structure will be failure in one day or at a time. It will give some sufficient warning also. That's why in the reinforced sections also we are having a balanced section, over reinforced section and under reinforced section. We never use under reinforced sections. Under reinforced sections will give the sufficient warning before failure. So we don't want to put more reinforcement, we don't want to put less reinforcement. We should always provide the reasonable or the balancing reinforcement. Then the structures will not be failure. And prevention and control. So what are the, I think that you are having the doubt, what are the preventions, what are the controls? Use a high quality of the concrete with the low permeability. The permeability is also very, very important. What is the permeability? The flow of the water in the concrete particles. Flow of the concrete water particles in the concrete itself. That is also high strength concrete we are going to design. If you have to go for M30, M35, M40, M45, M50 with the low permeability. Permeability is nothing but the flowing of the water particles in between the concrete. Is it right or not? And adequate cover thickness. I told already, cover is also very, very important. As in the case of the columns, we are going to use 40 mm. In the footings, we are going to use 50 mm. In the beams, we are going to use 25 mm. Like the slabs also 15 mm. Why? The cover will be required for placing of the concrete. Otherwise, if you are not providing the cover, why? How the concrete will place above the steel reinforcement. That's why the failure of the cover is also leads to one of the reason for corrosion of the reinforcement. Use corrosion inhibitors. So corrosion inhibitors are already available in the market. We are going to use those also. Use epoxy coated galvanized environment. Some epoxies is also available present days. Previously, it's not available because of the trending technology itself. Epoxy is also available. So we have to apply the epoxy. The corrosion will be arrested up to the certain level itself. Okay, so whatever the precautions we are going to take, in addition to that, we have to apply epoxy over the reinforcement or over the column boxes or the slab boxes. Some corrosion will be arrested up to the certain extent. Employ cathodic protection, not anode protection. Cathodic protection also we have to apply. Next, damage and assessment of the concrete structures. So after that, if the reinforcement you have to provide, after that we have to observe the corrosion of the reinforcement. So after that we have to damage the assessment of the concrete structures. What is the purpose of the damage assessment? To identify the type of the damage and extent and cause of the damage. So what is the cause of the damage? What is the extent of the damage? What is the quantity of the damage? So these are all the things we have to see that. Suppose if the damage will be very less, so we have to provide some necessary precautions, it will be over. If the damage will be more, if the damage quantum will be more, automatically we have to take it as a serious. Why? Because we are designing the structures, we are building the structures up to the 50 years span of the life of the structures itself. Suppose if the corrosion will be occurs automatically, in the meantime, day to day or year to year, it will be increases. Ultimately, it will leads to damage of the structure at any time. But it will not leads to the one day or 1 month or 1 year. So it is the long term, not the short term. So in the deflections also, we are going to discuss about short term deflections and long term deflections also, the cracking also. So short-term cracks and long-term cracks. Suppose if you are doing the plastering in the first day itself or the second day itself, we are seeing some short-term cracks itself. Those are not serious. But if you are seeing any cracks over the brick, that is the very dangerous. So that's why we have to see what is the intensity of the crack, whether the crack is to be small or large. We are already studied in the design of RCC structures also in the BTech level, and code book also it was there. So cracks is there and bond is there, everything shear is there, everything we have to be studied in the design of RCC structures. So that's why for the corrosion of the steel reinforcement, we are having the sufficient knowledge about the concrete structures itself. Next, to decide the urgent and necessity of the repairs. That is also we have to estimate before that. So what is the necessity? What is the necessity of the repair of the structure? What is the necessity of the urgent of the structure itself? So whether it is to be done today or whether it is to be done later, you have to decide based on the seriousness of the problem itself, seriousness of the corrosion of the steel reinforcement. So whether it is the bigger one or the smaller one, we have to analyze based on the physical identification to ensure safety occupants and users. So what is the purpose of the residential buildings or the commercial buildings or any structures? Suppose if you are constructing a dam, so it will be useful. So it will be useful to the public. So the dam is to be constructed for the storage of water, for the generation of the electricity, multi-purpose dams. Nagarjuna Dam was there. So we have to construct or we have to design the dams for the safety of the occupants and the users. So the buildings also. So buildings, so many people, they have to be resided. Family, father, mother and children, 4 people or 5 people are resided. We have to always see the safety of the occupants. That is the very, very important. Whether it is the strength aspect or the durability aspect or any other aspects, we have to see that ultimately our motto is safety of the occupants and to estimate the remaining service life of the structure. Suppose we are constructed in US in 2025. So after 10 years, we have to be observed some cracks or some corrosion of the steel reinforcement. So after that, you have to decide what is the total lifespan of the structure. Suppose the lifespan of the structure is to be 30 years. So after 10 years, we are observing the corrosion of the steel reinforcement. The remaining life is to be 20 years. If we are designing for the 30 years. So remaining 20 years, we have to see that what type of repair we are going to take for any other repairs or not occurs after 20 years. That is the remaining service life of the structure itself. The service life is to be very, very important. Whether the buildings or the dams or the roads or the canals or the bridges or aircrafts or whatever it may be. The lifespan is to be very, very important. Rapid assessment. Quick inspection mainly after events like earthquakes, accidents and sudden failures also. Suppose the earthquake will be occurs. So earthquakes will not give any sufficient warning, we know that. Some of the code books also there, we have to provide the reinforcement, earthquake resistance reinforcement also we are going to face. But unfortunately, we are facing some earthquakes anywhere in the India itself, anywhere in the world itself without giving any warnings. What are the precautions we are going to take? We are taking the reinforcement as per the earthquake loads also. We have to take what are the precautions we are going to take as per the guidelines given by the earthquake resistant design of the buildings IS 1883. Like that, there are so many code books are there. So based on the code books, we have to be designed. But unfortunately, we are facing the problems of the earthquakes or the sudden failures. This is the rapid assessment. So whenever the earthquake will be occurs, immediately we have to assess your structure itself. So whether the structure is to be safe against the durability aspects. Durability means against the floods or against the fire, against the earthquakes, against the cracks, against the deflections, the structure will be safe. Then the structure will be safe against the durability aspect. Suppose durability means manika in the Telugu itself. So that's why the durability means it is the lifespan, whether it is the 20 years or 30 years or 40 years or 50 years. So that is the very, very important. So against the floods, it will be safe. Against the earthquake, it will be safe. Against the fire, it will be safe. Against the cracks also, it will be safe. Against the deflections also, it will be safe. Okay, so that's why we have to see all the possible things. Either you can check against the torsional moment also, just like a twisting moment. This is the twisting moment. Against the torsional moment also, we have to be tested whether the building is to be safe or not. So that's why in the design of the RCC structures, we have to be short-term deflections, long-term deflections, torsion, shear, bond, everything we have to be decided. Shear also. So the structure should be safe against the shear, the structure should be safe against the torsion, the structure should be safe against the bond also, the structure should be safe against the deflections, either the short-term deflections or the long-term deflections. You know very well. So in the similar way, in the rehabilitation and retrofitting of the structures means that if the structure is weak, how to strengthen the particular structure? If the structure will be weak, how to strengthen? So how to strengthen, how to become the structure will be a remaining lifespan of the structure. I don't want to say that whether you are doing any rectifications or rehabilitations, you are not getting the original. So that is the very, very important, keep in your mind. What is the purpose? Identify the visible and obvious damage. Next, investigation of the damage. How to investigate the damage? Visible examinations of the cracks. Suppose if the beam is there, if the slab is there, if the column is there, automatically some cracks it will be visible by our naked eye. Or sometimes you are using non-destructive test methods. Suppose you are designing a column M40. So as per the drawing, you have to observe that the design of the column is as per the M40 grade. So without dismantling that particular column with the help of the non-destructive test, either the ultrasonic pulse velocity or the rebound hammer, we are going to test a particular column in the site with the help of the rebound hammer or the ultrasonic pulse velocity. We have to test it whether the column grade is to be M40 or not. In the similar way, slab also we are going to check. In the similar way, you are going to check the footing also, shear wall also. All the structural elements we have to be tested without any damage to a particular member, either the column member or the beam member or the slab or the staircase or the shear wall or the footing or water tank or whatever it may be. Then you can know that whether the grade of the concrete is to be correct or not. Suppose you designed M40, you got NDT value with the help of the ultrasonic pulse velocity or the rebound hammer is M30, you know that minus 10 newtons per mm square you are having. So based on that, you have to see that whether the structure will be safe instead of 40, 30, whether the load taking capacity of the column is to be right or not, you have to assess. So that is the indirect things. So direct things we have to see in physical cracks with the help of the naked eye. And other thing is that NDT and sampling of the concrete and steel for the laboratory test, carbonation test, chloride content, everything, rapid chloride permeability test was there, RCPT. So we had to test that concrete in the laboratory, how much chlorine content was there. So how much it is resist against the chloride content, we have to be tested in the laboratory with the help of the rapid chloride permeability tester. Next, carbonation test. With the help of the carbonation test, how much carbon it has to be you have to be tested. With the help of the rebound hammer test, we have to tested what is the original compressive strength of the concrete at a particular day or a particular time, whether it is to be matched with the original drawing or not, or executed grade or not, we have to be know that. So with the help of the ultrasonic pulse velocity also, we have to passing of the current in between the concrete particles, anode and cathode rays, we have to be tested whether ultrasonic pulse velocity is to be okay or not. The code book will give some values. If the values are okay, the concrete is to be safe against for further time also. And the structural analysis to check the load capacity after the damage also. What is the structural analysis? So structural analysis is differ from the strength of the materials. Strength of the materials is nothing but what is the materials we are going to use in the construction, whether it is to be safe or not. Suppose concrete we are going to use, so bricks we are going to use, steel we are going to use. So we have to test it in the laboratory. What is the strength, original strength we are having, whether the attained the original strength or not, we have to be tested in the strength of materials laboratory. Evolution of the surface and structural cracks. Surface cracks. Usually, surface cracks are caused by drying shrinkage. Already we know that what is the drying shrinkage, what is the thermal stresses or minor settlements. So, because of the temperature variations, we are getting some cracks. These cracks are called as the drying shrinkage cracks. Next, methods of the corrosion protection of the steel reinforcement. Corrosion inhibitors are there. Next, migrating inhibitors and admixed inhibitors are there. So, the chemicals are used to the chemical mix or applied on the surface to slow down, prevent corrosion. I told already in the earlier slides also, we have to apply some epoxies, we have to apply some liquids, we have to reduce the corrosion of the reinforcement. I can't say that we don't want to reduce the zero, we have to reduce up to the certain minimum to minimum. So, instead of 50%, you have to reduce 40% also, it will be safe up to certain extent. That's why these are all called as corrosion inhibitors. These are all already available in the market itself. Admixed inhibitors also. So, whatever the concrete we are going to use, additives or admixtures or retarders, in the similar way, the corrosion of the reinforcement prevention also we are using the migrating inhibitors and admixing inhibitors also. Next, what is the conclusion? So, what is the conclusion of the today's slide is that, so in the concrete structures, reinforced cement concrete structures, the concrete is only take care of the compression, and concrete is only take care of the compression. Steel is take care of the tension itself. Concrete is very strong in compression, very weak in tension. Steel is very strong in tension. That's why we are going to provide the reinforcement in the form of the main reinforcement or a distribution reinforcement or circular reinforcement or whatever it may be. Suppose circular water tank, we are providing a circular reinforcement. A rectangular water tanks, we are providing a rectangular. Next, square columns. So, hexagonal columns also we are going to use. Whatever the columns we are going to design, whatever the beams we are going to design, whatever the slabs we are going to design, steel plays very, very important role. And so, that's why the steel should be very strong and at the same time steel will not be corroded. That is the one of the things. Suppose concrete is not corroded. Suppose if the concrete is subjected to water also, there is no damage. Suppose if the steel will be subjected to water, automatically the corrosion will be occurs. Why? Because of the carbon plus oxygen, corrosion will be occurs. With the help of the oxygen itself, presence of oxygen, the corrosion will be formed. So, automatically the corrosion will reduce the strength gradually, not at a time. It will gradually reduce 1%, 2%, 3%, 4%, like that. In the meantime, it will reduce at a particular time, it will not split into the two parts. It will reduce our strength. Suppose our body is also, suppose if you are facing any headache or cold or fever or any other thing, we didn't reduce our power 100%. We have to reduce 30%. Some people are 40%. Some people are 90% also. Suppose if the person is lost 100%, he may lose his life also. In a similar way, some structures also collapse because of not in a particular day, not in a particular year. In the meantime, if you are not observing properly, if you are not taking properly against the corrosion of the steel reinforcement, it will be a big damage. Suppose if you are observing, if you are prevention is better than cure, and my dear students, prevention is better than prevention is better than cure itself. Suppose if you are observing properly at a particular time, if you are applying any possible things also, you have to reduce up to the great level, you are getting the maximum benefits also with the minimum effect. Suppose if you don't care about that, suppose if the steel is corroded, suppose if the steel will be subjected to water also, if you are not taking any care, if you are not taking any precautions, automatically it will lead to the major damage. So, that is the main conclusion. Corrosion of the steel reinforcement is the primary cause of the deterioration of the reinforced concrete structures. So, I am telling deterioration means to reduce the strength in the meantime. To reduce the strength in the meantime, not a particular day or a particular month or a particular year itself, significantly affect the durability aspect. So my dear student, any structure will be designed against the strength aspect as well as the durability aspect also. That's why we are going to tested in the laboratory concrete mechanical properties as well as the durability properties also. Mechanical properties means only compressive strength, flexural strength, split tensile strength, Young's modulus. These are all only mechanical properties. The durability properties means water absorption. How the concrete absorbs the water. That is the water absorption test, porosity test, and rabbit chloride permeability test, acid resistance test. These are all different tests are there. Carbonation test, void ratio test. These are different varieties of the tests are there. So because of these tests, we have to assess what is the durability of a particular structure. Strength is okay. So whenever you are going to construct a column, the column is in the same position. So durability means when the column is subjected to different loads, when the column is in same position or not, that is the durability, my dear students. Strength is different, durability is different. This is the left hand, this is the right hand. In the similar way, strength is left hand, durability is right hand. Both very, very important as per the human being. In the similar way, the structure also, whatever the structure we are going to design or constructed, equally important for the strength aspect and durability aspect. But the corrosion of the steel reinforcement is the durability aspect. It is a very, very important. Okay, and safety and service life. It occurs mainly due to the breakdown of the alkaline environment. I told already, because of the environment. You see that present environment is also atypical. So morning sun, afternoon rain, evening cold like this. So environment is to be changed drastically within the 24 hours. Previously, the environment is not changed within the 24 hours. So we are having rainy season, we are having a cold season, we are having only hot season or summer season. So only 3 seasons we are having on. Instead of 12 months, 4 months is rainy, 4 months is cold, 4 months is summer. Nowadays, within the day, we are seeing all the 3 seasons. What is the reason for that? Because of the air pollution, because of the noise pollution, environment will be polluted. So because of the environmental conditions will be changes automatically, we are facing the problems in the durability of the structures also, strength of the structures also, strength of the life of the human beings, durability life of the our life also. So because of the environment, so it will affect the service span of the structures also, service span of the human beings also. I am not saying only service life of the structures, service life of the human beings also affected because of the environmental condition changes. You see that in the present Hyderabad or present in India also, we are having three different seasons within the 24 hours. So how our body will support? Our body will support against the rain, against the wind, against the cold. How many bodies are having a sustainability against all the 3 within a day or within the 24 hours or within the 10 hours? It is very difficult. Some of the people they are okay against some of the people, their body is not supported against those environmental conditions. So that's why I am telling environmental factor is also very, very important. The resulting corrosion leads to the cross-sectional area of the steel section. That is the very, very important, and spalling of the concrete also, and structural integrity also. These are the 3 things I have to be again explained. So because of the corrosion of the steel reinforcement, the area, cross-sectional area of the steel will be reduced. So instead of 16 mm, it will become 12 mm, or sometimes it will become 10 mm also. So you are designing a particular structure 4 bars of 16 mm or 4 bars of 12 mm. So because of the corrosion of the steel reinforcement, instead of 416 mm will be reduced to 412 mm, automatically the area will be reduced. Is it right or not? So that's why it is the very, very one of the reason cross-section area will be reduced, and the spalling of the concrete, that is also very, and third one is structural integrity will be disturbed. So structural integrity means it is the unity of the structural. So why? Because in the building different structural elements are there. We are having slabs, beams, columns, staircases, shear walls, footings, floorings. There are so many water tanks. There are so many structural elements are to be there in the within the building itself. That integrity that combination is to be, that structural integrity means that collision will be very, very important. Otherwise, it will be very problem. There is no the difficulty between one element to the another element. All the elements are having the good structural integrity. Then only we are getting the good durability of the structures also. So, in the today slide, what is the final conclusion of this? In this, first of all, I had to we had discussed about what is the corrosion of the steel reinforcement, what is the mechanism, how to detect the corrosion of the steel reinforcement. So, what are the necessary methods are there, what is the mechanism is there. So, what are the methods are there to protect these. Next, what is the importance or what is the conclusions of this things we have to be discussed. And finally, early detection and regular damage assessments are crucial. I told already this is the one of the very, very important. Early detection and regular damage assessment. Early detection. Suppose sometimes we are doing the concrete of the columns. The cover will be missed. Immediately on the next day itself, whenever removing the shuttering, we have to apply some epoxy or some plastering. The rods are not exposed to the atmosphere. When the rods are not exposed to atmosphere, automatically corrosion will be arrested. So that's why early detection is to be very, very important. Prevention is better than cure. In the similar way, early detection of the corrosion of the reinforcement. If the reinforcement is to be exposed to the atmosphere, automatically the corrosion will be develops inside the concrete only. So that's why we have to see immediately, and immediately we have to take the necessary precautions to fill the gap. So why? Because in the structures at a time we are going to do the slab and beam concrete also a bigger area. So it is not possible to see inch to inch also shuttering also. Shuttering also plays very, very important role as per the corrosion of the steel reinforcement, and providing the reinforcement also in the proper way. We have to provide the clear gaps also, one bar to another bar, how much gap, just what is the clear cover to the beams, what is the clear cover to the slabs, what is the clear cover to the slabs, what is the clear cover to the footings, everything we have to be see that. Otherwise, each and everything is having some importance, and suppose cover is having some importance and individual distance between the individual bar, that is also plays some importance. Finally, each and every item plays some importance. Ultimately, it will place most of the importance. Early detection, regular damage assessments are crucial to preventing severe deterioration. If you are observing early detection and you have to take the care, we have to reduce the things up to the certain levels itself. Next, these are the column I have to shown. Next, these are the reference slide links. So if you are having any queries, please comment. Thank you.